Alright, so now we're going to start on chapter 11.5. And chapter 11.5 takes us into something you're going to be using for the rest of 6th grade, junior high, high school, and as long as you continue on in your education in mathematics, you're going to be having problems dealing with volume. Volume is used in mathematics and all your advanced mathematics classes. It's also going to be used in chemistry and your science classes. So this is something we've got to understand, and we're going to build the basic. And as long as you follow along and do as I ask, then you're going to get it. The slideshow took me an hour or 3 hours and 22 minutes to make. There's 103, 104 slides to the whole entire thing. If it took me that long to make it, just so I could teach you, then all I'm asking is for about a half an hour for you to follow along, pay attention, take the notes, and learn this basic information that's vital. And when I say vital, I mean vital. You have to understand volume for the next 6+ years as long as you're continuing on in your education. This is not difficult as long as you apply the effort that I'm asking by paying attention, follow along, take your notes, build that muscle memory on working out these problems, and then we'll continue forward in chapter 11 over the next few lessons. Volume is the idea of taking this three-dimensional shape and filling it with something. Now, it could be units, it could be square or cubic inches, it could be cubic centimeters, it could be cubic miles. It doesn't matter what the measurement is. What matters is that I know that I'm filling up this three-dimensional shape. And I have to figure out the math on how to fill up and make the measurements so I know what my answer is. So when we look at it, this gives you a fancy definition. Volume is the measure of the number of unit cubes needed to occupy a given space without gaps or overlaps. You can find the volume of a rectangular prism by seeing how many unit cubes it takes to fill the prism. So what that is saying is, well, how many smaller blocks does it take to fill up the bigger block? Okay, so I have a rectangular prism here, and I could figure out how many there are by trying to count. When I look at that, I can't see all of them, can I? So I have to figure out how many different layers there are, how deep it goes, how tall it goes. I could change the colors to make it easier to see, and then I could count. The measurements I would count would be a length, a width, and a height, or a base, a width, and a height. So here, if I look at just the height, I have 5 different layers of even blocks. When I look at going across then, I have 5 different columns going straight up and down of even blocks. And then I also have to look at my width, which is 2. Now, I could look at it differently and from a different angle, same colors and same patterns, but I still am going to have a depth of 2, 5 simple columns, 5 simple rows. So then I can figure out how many of those little blocks it is that make up that big block. If I take my 5 times my 5 times my 2, my base times my width times my height, or my length times my width times my height, it doesn't matter what words I use as long as I understand what those are meaning. Base and length means the same thing. My width is how far we're going back, my height is how far up it goes. If I multiply 5 times 5, I get 25, and multiply that by 2, then I get 50. So I would know that there are 50 small cubes that make up this rectangular prism. That's what volume is. How many does it take to make it up? Now this is trying to get you to think, if I have a big block that's measured in 1 cubic unit. So it has 1 unit across, 1 unit up, 1 unit back, and we're just going to say it's a yard. So this is 1 yard by 1 yard. It says gives us a unit because it'll apply on any measurement that I use. Centimeters, millimeters, inches, miles, it doesn't matter. What it wants us to understand is if I say that each of those little blocks is a half of a unit, well then how many little blocks does it take to make up 1 whole cubic unit? So when I start to fill it up, then I'm going to fill it up with individual blocks that are all the same. Half of a unit by half of a unit by half of a unit. So how many would it take to fill in the whole bottom row? It would take 4, right? Because here's 2, and then I complete it with 2 in the back. But then I would have 2 rows to fill up. I'd have another 2 in the front and 2 in the back. And so if the bottom is 4 and the top is 4, then I know to fill in that whole entire block that is 1 cubic unit, 1 by 1 by 1, then I'm going to have 2 of these half cubic unit smaller boxes. So I would have 2 going this way, and 2 going this way, and 2 going this way. So I'm talking about multiplying 2 times 2 times 2. So if it is truly 1 cubic unit box, and I talk about filling it evenly with smaller boxes that are half a cubic unit, it's going to take 8 of those small boxes to fill it in. So when we have questions about this half a unit, that's going to be on a Moby Max lesson, that's going to be on NWEA, that's going to be on iStep, right? And it's going to be on your homework for the next couple of lessons. Well, if I have half units filling in for the whole units inside those three-dimensional shapes, it's going to take 8 for every 1 cubic unit that I have. This big cube is 1 cubic unit because it shows it has a unit measurement of 1. So this is 1 and this is 1. But it takes 8 of the half unit measurements to make it up. Notice that there are 4 in the front and 4 in the back, or 4 on the bottom and 4 on the top. So every one of them is actually 1/8 of the overall measurement. We're going to be able to use that to figure out also how many smaller cubes are going to make up the area. So let's look at what it's talking about. We're talking about taking our base times our height times our width to find out the measurements, but then we're also going to apply that to having 8 smaller half units for every 1 unit that's cubed. So I would take, in this case, 2 times 2 times 2, so I know that it is a unit measurement of 8 for my area. So when I look at this situation then, when I have C, it says I'm going to use this jewelry box, and this jewelry box has 3 measurements. 3 1/2 units, 1 1/2 units, and 2 units. I want to figure out how many of those half unit cubes take to make it up, and I want to figure out, well, what is the volume of this jewelry box? So when I use those numbers of a length of 3 1/2, or base of 3 1/2, a height of 1 1/2, a width of 2, I can figure out both of those questions. Now, using fractions inside of a math problem and mixed numbers doesn't work, does it? They all have to be shown as fractions. And that means if it's a mixed number, I gotta have improper fractions. So reviewing how to do that, because I have 2 mixed numbers here that I have to make improper fractions. So I set them up, and then I start at the bottom, and I multiply and add. We've gone over this many times, okay, so we should remember how to do it. If I start at the bottom and I multiply, I have my 2 times my 3, and that gives me 6. And then I add for my new numerator, and 6 plus 1 is my 7. I do the same thing with 1 1/2. Start at the bottom, 2 times 1, because I multiply and add. 2 times 1 is 2, plus 1 gives me a numerator of 3. I want to keep my 2 right now because there's nothing I need to do with it. But then I have to establish my denominators. And on my denominators, I just keep the original denominator that was there. So this has a denominator of 2, so now my numerator is 7, so I know I have 7 halves. My denominator here is a 2. I have a new numerator of 3, so I know it's 3 halves. When I'm dealing with fractions then, I also have to make my whole number into a fraction by simply putting it over 1. Then I can do my math. What math am I doing? I'm finding my base times my height times my width, so I'm going to multiply the 3 together. So I have 7 halves times 3 halves times 2 over 1. So when I multiply those together then, I'm going to multiply across. Multiplying across means to go straight across. I have 3 times 7, which is 21 times 2, so I have 42. And in my denominators, I have 2 times 2, which is 4, times 1, which is 4. So I have 42 fourths. Then I have to reduce, don't I? So now I'm going to reduce. Both of these are even numbers, so I'm going to take 2 out of both of them. 2 goes into the numerator and 2 goes into the denominator. So when I reduce by 2's, I'm going to get 21 halves. Now I'm going to pause there because this math problem, I've shown you an easier way to do it. I teach shortcuts for a reason. There are some of you that don't like to learn the shortcuts because you think I'm trying to teach you extra math to remember. I promise you I'm not. What I'm trying to teach you is a sound mathematical practice or sound mathematical tool that will always use, that you can always use, and you can always be successful with because it works every single time. There's nothing wrong with the math, it just eliminates one of the steps that you're going to have to do. When I have fractions, I don't like dealing with big numbers unless I absolutely have to. We're going to get to a problem here in a moment where I have to use a big number because there's no reducing that I can do. But when I have this math problem, I have 7 halves times 3 halves times 2 over 1, I can cross reduce to make it easier math that I have to do. I have a numerator and a denominator that's the exact same thing. So if I just cross reduce, then I just cross them out and they both become 1. Once they become 1 and I multiply across them, my math is easier. I have 7 times 3 times 1, and then I have 2 times 1 times 1. That gives me my 21 over 2. Now look at what we had before. Before, we had 21 over 2, but I had this bigger fraction that I had to that I had to reduce by 2's, or once I divided, I was going to have to reduce that fraction. And the problem is when I don't do it over here, I end up forgetting when I divide that I have to reduce the fraction. So if I always make sure that I cross reduce, as the shortcut indicates inside the math when it's set up first, then I can go from here. Now going from here, I have 2 different answers that I'm going to solve for. I'm going to solve for C and I'm going to solve for D using this 21 halves. So let's look at what the 21 halves does with C. If I know that I have 21 halves, and it says now if I have half unit cubes to make up this 21 halves, then how many cubes do I have altogether for this entire shape? Well, if I have half unit cubes, what did we say was true about a number relationship? Well, we said that I know that for every 8 half unit cubes, then that's equal to 1 overall. So I would have to divide by 1/8, but we know we can't divide by 1/8. So we have to keep the first one. Division would become multiplication. Flip the second fraction, so I know instead of dividing by 1/8, I'm actually going to multiply by 8 over 1. So when I have 21 halves times 8 over 1, once again, that's going back to the idea that for every 1 cubic unit, if I have half unit cubes that I'm measuring with, then I know that I have 8 of them that make up one big one. So I'm going to take my 21 halves times 8 over 1. I'm going to cross reduce because I can. It makes my math easier in the end. 2 goes into 2 one time. 2 goes into 8 4 times. I'm left with 21 times 4. My denominator is 1 over 1, or is just 1 times 1, so it's 1. So whatever I get as my numerator, that's how many little cubes I would have to make up the bigger shape. 21 times 4 is 84. So I know for C that if I'm using my half unit cubes, then I would have 84 of those smaller ones to make up one whole unit cube. On D then, to go a step with the 21 halves, I want to then find out what the actual volume is. And so I just finish up the math problem. I take my 21 halves and it's division, so I'm going to divide my numerator by my denominator, and 21 divided by 2 gives me 10 and a half. So I know my volume is simply 10 and a half cubic units. Now this was telling you to do something different in math, and I don't need you to understand what they're saying, but it does work sound mathematically. If I take my 84 and then I go back and divide it by the 8, I get 10 and a half. The way that math is set up, it's not something I need you to do. I just need you to be able to take the length times the width times the height, multiply them together, and then solve for your volume. You would still get the same answer either way. But what I want to look at now with is our cubic units. So in area, in chapter 10, we've dealt with area and we dealt with surface area. And it was always multiplying two things together. We always had a base and a height that we multiplied together. They had the same units, so we always squared our label. Well, now when I look at this, I have this measurement, and this measurement, and they all have the same unit for the measurement. So I now have 3 of them. So every volume question is going to have a cubic measurement. You can take and write cubic units if they don't give you something specific like inches or meters or miles, or I can write it with a 3 as the exponent. Why a 3? Well, in area, once again, we multiplied 2 things together, a base and a height, so I had a exponent of 2. On volume, I'm multiplying 3 things together with the same label, so I'm going to have an exponent of 3. And the little 3 as an exponent just means it's cubed. Going on then, drawing conclusions. Can I take the same idea of filling up 1 cubic box and figure out how many it's going to equal in the triangle? Well, that answer is no. I can't do that. Because if I just use the same math, I would have to have a cube. So my reasoning is, well, the answer is no, but the reason that I can't is because it would cut the boxes that are in the corner in half to make this diagonal for this triangle. Mathematically, it's not good, sound math work. I wouldn't be able to solve for it. So no, the corners would cut boxes in half to make the diagonal for the triangle. I will tell you that we're going to look at how to do that, and we'll be able to solve a problem like this for the volume of a triangular prism. Right now, we're just sticking with the base times the width times the height. This question then says, well, how many cubes with a side length of 1/2 unit? Okay, so that goes back to that original question. There are how many smaller half units that make up 1 whole unit? This question, I'm going to have an answer of 24. How did I get that? Well, that goes back to this idea that for every 1 cubic unit, if I use half units to make it up, I'd have 2 times 2 times 2, which is my 8. So I know that if I have 3 units, and I'm using these half units like it says, that 8 times 3 gives me 24. So the answer is 24. If I have 3 units, and there are 8 half units for every 1 unit, then 8 times 3 equals 24. If you didn't get that right written down, please pause the video. Once you're done, unpause it, and I'm moving on. So question 1 then, that's just going to deal with these half unit measurements. Every time I'm going to put it in groups of 8, because 8 half unit measurements equal 1 whole cubic unit. A prism is filled with 38 cubes with a side length of 1/2 unit. What is the volume of the prism in cubic units? So if I know that it's filled with 38 cubes and they are half cubic units, then I'm going to divide it by 8. 38 divided by 8, going back to this idea that it takes 8 of them to make 1 whole unit, that is 1 unit by 1 unit by 1 unit. Then in my 38 divided by 8, it's going to be 4 with a remainder, right? Because 8 goes in 38 4 times, which is 32. 38 minus 32 is 6. Have to remember how to write my fraction as with my remainder. My remainder is always my numerator. My divisor is always my denominator. So I start with 4 and 6/8, but notice they tell you there's another equal sign. That's to help you remember that that then has to be reduced. They're both even, so 2 goes into both of them. So if I take 2 into both of them, 2 goes into 6 3 times, and 2 goes into 8 4 times. So my answer would be 4 3/4. 4 3/4 what? Well, I have 4 3/4 cubic units, or you could use the unit with the exponent of 3, which also says cubic units. Same type of problem here, but instead of 38, we're now going to use 58. So I'm going to take 58 divided by the 8 once again, because we're using half units. Anytime I have a half a unit that it's asking me about, I know I'm going to divide it into groups of 8. So my 58 overall cubic units divided by 8 tells me that 7 goes into 856 times with a remainder of 2. Same process on how to write my remainder as a fraction. My remainder is my numerator. My divisor is my denominator. So I know I'm going to have a numerator of 2 and a denominator of 8. Have to reduce my fraction if I can. 2 goes into both of those. So I'm going to get 7 1/4. 7 1/4 what? 7 1/4 cubic units. I multiply 3 sides together, so it has to be a label of 3. Now on these two, it's just straightforward finding the volume. And what's the formula for volume? Well, I know I'm going to take my base, I know I'm going to take my height, I know I'm going to take my width, and I'm going to multiply all 3 of them together, and then cube my label. Here I have 3, 5 1/2, and 2. So I have to make the 5 1/2 into an improper fraction. Starting at the bottom, multiply and adding. 2 times 5 is 10, plus 1 gives me 11, and I keep my denominator. And what do I do with my whole numbers to do my math? Hopefully you thought I put them over 1, because that's exactly what we're going to do. So I have my new numerator of 11. I keep my denominator of 2, so I have 11 halves. I'm going to multiply it by 2 over 1 and 3 over 1. I'm going to cross reduce where I can, and there's one place that I can cross reduce. I have a 2 and a 2. 2 and 2 go into each other one time. So when I cross reduce to make my final step easier, I end up with 11 times 1 times 3. And in my denominator I have 1 times 1 times 1. That's much simpler, because I have 11 times 3, which is 33 over 1, and I know that that's just 33. So I'm going to have 33 what? Well, once again, 3 things that I multiplied together tells me that I'm going to have a cubed label, so I'm going to have my units cubed, or units to the 3rd power. Number 4. Well, I've got 4 1/2, 4 1/2, 4 1/2. Once again, base times height times width. I have to take all 3 of those measurements, multiply them together. I have mixed numbers again, so I have to take all of them and make them improper fractions. Now, you can write all 3 of them if you want, or you can show me one time that you know that 4 1/2, I would start at the bottom and multiply and then add, and have 2 times 4, which is 8, plus 1, which is 9, which would give me my 9 halves. And then you could write it 3 times. If you want to show all 3 times, I would never count it wrong for showing extra work. So I have 9 halves, 9 halves, 9 halves, 3 different times for my base, my width, and my height, and I'm going to multiply them together. Now, a moment ago I said that if I can't cross reduce, I have to work with bigger numbers, and this is what I meant. Because when I multiply on my handy dandy calculator 9 times 9, I get 81, but I have to multiply that by 9 again. And when I do that, and I multiply straight across my numerators, I get 729 over 2 times 2 times 2, which is not 6. 3 times 2 is 6. But 2 times 2 is 4, and 2 times 2 is 8. So I have 729 over 8. There wasn't anything I cross-reduced, so I just have to do the math problem the way it's written. There I have to use the bigger numbers. When I divide my numerator of 729 by my denominator of 8 then, and I multiply through, I get 91. 8 goes into 72 9 times, which is 72. I bring down my 9, and 8 goes into 9 one time, with a remainder of 1. Have to write my remainder as a fraction. My remainder is my numerator, my divisor is my denominator. So when I put those in the proper places, I know I have 91 and 1/8. So 91 and 1/8, I make sure that I keep my number correct, and I put it with the proper label, which 3 things multiplied together tell me my units is cubed. So to the 3rd power. 91 and 1/8 cubic units. My last 2. So I have Theodore, same name as President Teddy Roosevelt. Theodore wants to put 3 flowering plants in his window box. The window box is shaped like a rectangular prism that is 30.5 inches by 6 inches by 6 inches. Now the question is a yes or no, an explanation, but I have to show the work in order to be able to answer the question. Now all along we've used fractions, but they gave me a decimal. I'm going to stick with a decimal. 30 times 5 times 6 gives me what? Well, 30 times 5 times 6 is going to give me an answer of 1830. When I type it into my handy dandy calculator though, I only get 183. That confused a couple of you on your work the other night. Well, if I remember that I have this 1 decimal point, so I have to move my decimal point to the left 1 time, I would see that why my calculators tell me it's 183 when I'm doing it, I show 1830. Well, that's actually 0.0, which I'm going to get rid of. It's just 183. But then I have to multiply that by the 6. So I'm going to show 183 times 6, and when I plug that in, after I write out my math problem, I get 1098. No decimal points. So I know I'm talking about 1098. So now look at the question. In order for these flowers to be healthy, they have to have 1,200 cubic inches of soil. His box only holds 1,098 cubic inches of soil. Is it big enough? Now I look at my answer. It's a yes or no answer, and in this case, it's going to be a no. The answer is no, and why? Now I have to explain. I have to use my words. The box will only hold 1,098 cubic inches, and the flowers need 1,200 cubic inches. It's not big enough. It's a very basic answer, but it provides me with all the information that I need. So please pause the video and write down the rest of that answer before you go on. Moving on then, that finishes up the questions that we're going to be doing. I made 101 slides. It took me 3 hours, 22 minutes to make all the slides for you, and I've been recording for 26 minutes and 38, 39, 40 seconds now. I'm asking for about 27 minutes of your time for 4 hours of work that I put in for you to be successful. I've explained it the way that you need to know and that we can build on for the rest of Chapter 11, for the rest of your 6th grade math year, and from this point forward, this same lesson that you can apply for the rest of your education career where you're going to be learning and studying about math. You're going to have to do volume. In science, you're going to have to do volume in math. Not here, all the way through Western Boone or wherever you go through junior high and high school. So please take the time that I've asked you. I'm doing the best that I can for you as your teacher. I need you to put forth a little bit of the effort that I'm putting in to make you successful, for you to be successful. So understanding that we're talking about volume, we're talking about 3-dimensional shapes, how much will fill up the shape. I know that my formula is base times height times width. You'll see it printed in other places as length times width times height. It doesn't matter which one you use, they're all the same meanings. Always remember that my label is cubed. I multiply 3 things together, so I cube my label. So you have some questions to do, not a lot, but you do have some questions to do, and then you have the other assignments that I now have listed on a piece of paper for you that you're going to be doing throughout the week in order for Thursday to be a good day. If you watch the video, you filled in your book, you don't understand it, then please come and ask questions.